Okay, so if we have, we'll talk about control statements tonight. And suppose, for example, we had some code that let's say we were a bank and we were managing bank accounts. And we had float, account 1 equals $100, and float, this would all be small letters, but account 2 equals $200, and float account 3 equals $500. And then let's say we decided we wanted to give interest to each of these accounts, 2% interest to each of these accounts. So what would we do? At some later point in our code, we would say something like ACCT1 equals ACCT1 times 1.02, and then ACCT2 equals ACCT2 times 1.02, and then ACCT3 equals ACCT3 times 1.02. And we gave the three accounts 2% interest, right? Okay, suppose we had not 3 accounts, but suppose we had 2,000 accounts or 20,000 accounts.
And you don't wanna be writing each line there, right? By
This line, well, how we initialize the accounts, let's pretend that's already done. Our task for today is just to give everybody interest. We'd have to write this line 20,000 times, right? Right, so that would take a long time. There'll be a lot of cutting and pasting. So if we organized the accounts, so these accounts, these are just really names. I just said ACCT and then a 1, 2, 3. These are just random names. Since they're all the same, we could use this concept called an array, which is basically a collection of similar data fields, but instead of them having their each individual name, we give them one universal name, like accounts. So it could be like account, say OU, account, and then it's actually a collection of account values. And in this case, they're just floating point numbers. But so this would end up being an account, and then we have to say like account, you know, and then have a number for each one of those, account 1, account 2, and so on. But if we gave it one big name, like account, okay, let's say accounts with an S, then we want to have an index, a number that tells which account. Do we want account 1, account 2, account 3? But we're basically giving it one big name. So it's kind of intuitive. I think some people think it's intuitive to have the first one be number 1, second one to be number 2. But, and I kind of think that's initially intuitive, but what they like to do is they like to say, well, this is a location in memory, and then, so like this location, starting right here, is addressed by the word accounts, and then we want to say how much more do we want to add to that, and if we started with 0, then accounts plus 0 means go to the very beginning and go to the first one. So it's kind of a tradition to, even though it might be a little intuitive to say, well, if I have 10 accounts, they should be numbered 1 through 10. If you just remember, this gets added to the beginning, and the first one starts at the very beginning. So we'll start with 0 and go through 9. Or if we have 20,000 accounts, we'll start from 0 and go through 19,999. Okay, so it's just adding that offset to where it begins. Okay, so then this code would change a little bit. We'd have to somehow be able to say accounts, the 0 one, the accounts, the second one. So it would go something like this. Well, let me just change. Let's assume the accounts have already been declared. The way we would go and add the interest would be accounts 0 equals accounts 0 times 1.02. And now I'd have to do it again 2 more times, right? Nothing really changed, we're using arrays, so it changes the names. Instead of having the 1 and the 2 and the 3 embedded in the variable name, we just have an array name with a number. So not a whole lot has changed yet. Accounts 1 is equal to accounts 1 times 1.02, and then I do one more. Now if I want to do this 20,000 times, I still have to write this out 20,000 times, right? For all the accounts, I'd have to write out all that code just to do this once. And we're actually performing the same exact operation over and over. We're taking whatever the value is, multiplying it by 1.02 and storing that value back. But this would still take 20,000 lines of code, and yet we're doing the same thing over and over with one difference. The number we're doing it to changes. So the first line of code would change this one, add 2% interest to this one. The second line of code would take this box and add 2% to itself, and so on, right? And if we had 20,000 accounts, we'd have to write 20,000 lines of code. So that would be a lot of cutting and pasting. Wouldn't it be nice if there's some way we could say, instead of doing it for 0, and then doing it for 1, and then doing it for 2, wouldn't it be nice to say, let's do it for something vague, and tell that vague thing to go from 0 to 1,999, right? So, if we
Without
could,
totaling it, like, right? Because that's one of the things, is that it might total, if you don't do it right, it'll total the account and add 2% to the total.
to the previous accounts,
The total of the accounts, like, just say up there you have 800 total, $800.
right, yeah, we wouldn't want, like in this case, we wouldn't want the first account to be 102 and then the second one to be 305, we wouldn't want to.
2%, right.
So we wanna be able to
stay
do-
incremental.
Right, we want to do something like this, but since we're doing the same thing over and over, it's just being done for each account. It would be nice if we could, instead of doing it for 0, let's just do it for something kind of vague, like a variable. Well, suppose we did this for so a popular letter to use is the letter I for index, the first letter of index. So I represents the index, so if this is I pointing to this one, then if we could just make I equal to a variable like 0, if I was equal to 0 initially, then accounts 0, that's this field, equals accounts 0, this field, times 1.02. So if this was $100, after these two lines were done, right, I'm just saying I is equal to 0. Oh, I have to make this an integer, sorry. Integer, I equals 0. These two lines would actually do what we just had before. It would take this number and make it a 102. So we added interest to that account, right? It just looks like we made it a little harder. Why did we make 2 lines when we used to have 1 line? Right? But we could do this. We could make a separate variable called I. Okay. Now what we could do, and you might think this looks strange, we could say I equals I plus 1, and then write the next line exactly the same as this one. This is kind of what we had before.
So it wouldn't be adding 1 to the total, like to 500 or just 200. in account two.
Right, so this
It wouldn't be making it 201, it would be adding one instance of 1.0 or 0.02 to that space, to 1.
Well, no, okay, so the first, so what we've done is we've added this new variable called I. So I is new, and it equals 0. Right, I made I equal to 0. And,
Which is the first spot in the array.
yeah, even though they're not really connected to each other, we're gonna use it for that. So it refers to the first spot in the array. So now, if I say accounts I equals accounts I times 1.02, what that'll do is it'll go to accounts, add 0 to that, so that means this box with the 100, and say this box equals 100 times 1.02, so that'll make this a 102. Right, so this field is now 102. So that's, after this line is done, the first account has been given interest. Now what I'm doing, and I know this sounds a little strange, I'm now saying I equals I plus 1. So that makes this happen. Now I run this line of code and this line of code is exactly the same, but the value of I has changed. So now accounts 1, this account, equals accounts 1 times 1.02. So that would give 2% interest here would be 204.
It's just making the code move through the array by one spot.
Right, so basically if I copy these two lines, if I copy these two lines over and over and over, I don't have to change anything, right? They're exactly the same. The first line takes I and adds 1 to it. The next line says whatever I is, add interest. So now I'm making life a little bit easier. I could cut and paste this and do this 20,000 times. But at least I don't have to manually change anything, right? Because I'm going to keep doing the same thing over and over and over. So really, this is the thing that just repeats, and this will repeat for I is equal to 0 to 20,000 or 19,000.
So there's got to be a code to get that section to repeat automatically.
Right, since this is the thing we keep doing over and over, what do we really have to do to get it started? We have to give an initial value, and we have to give we don't want this to just go on forever. We have to tell it when to stop. But really, this is the thing that keeps happening over and over and over, right? So there's a way to code this. It starts to get this thing getting repetitive. We can do exactly these two lines plus these two lines repeated 20,000 times. We can do that by saying this. We have to somehow say where we're starting. We have to somehow say, give us a way to stop. But the thing that just keeps happening is this line. So we could say, the syntax goes like this. For, we'll create this variable I. We'll say int, we have to declare it, integer I equals 0, and then semicolon, because that's a complete sentence, a complete statement. What do we want to happen every time we do one pass? Every time we give interest to an account, what event do we want to happen? We want I to be increased by 1. So then we can say, sorry. The next thing would be, when would this thing stop? We want this thing to stop when I
is equal to
or greater than, just to be safe, is equal to or greater than.
Oh no, wait, is it that or the other way? Equal to or less than. Yeah, equal, because you want it to cap at 2,000, right? I is equal to
or less than, or less than or equal to? Less than or equal to?
Maybe 2,000.
Well, you know what?
What?
Well, it's gonna, yeah, this is just kind of a detail when it exactly stops, but let's say as long as it's less than 20,000.
Okay.
That means as long as it's, 19,999, it'll go, but then it'll stop at this point. And then for each time this happens, what would we like to change? We would like I to change by saying I equals I plus 1. Then what should, now we say open paren, close paren, and we say, what do we want to happen when each time I changes? And that's this one line. So let's say accounts I equals accounts I times 1.02. So these lines right here, these 1, 2, 3, 4, and actually, you could make this one long line. You could have made this, you could have put the open paren over here, and then this line after it, and then the close paren. You could have actually made the whole thing in one line. But this would do exactly the same thing as the 20,000 lines, or maybe 40,000 lines, since we had 2 for each step at this point. So that's what this would do, and it would do the same exact thing. It creates this variable called I, this separate variable. I starts at 0. I keep this line of code runs, then we come back up to the top, we increment I one more time, we check, did we go past this boundary? And if we haven't, we run this line of code again, come back up to the top, and this will take 20,000, the amount of time it takes to run 20,000 times, but it only took 3, 4 lines of code. If you count these open paren, close paren as a line of code. Okay, so this ends up being what's called a for statement. So a for statement is basically, you know when it's going to start, and you know exactly when it's going to stop. And then you just, each time you have to, something has to change, otherwise it's you doing the same thing over and over. So here's where you start, here's where you stop, here's what changes. And then each time, this is what gets done. So then the idea came along, what if sometimes you don't know when you're going to stop? Suppose you want something to keep happening over and over, but you don't know when this thing is going to stop. Then we wouldn't be able to write a for statement and put the stopping condition. So the for statement says where we start, where we stop, and what changes each time. So let's say, for example, you asked somebody a question, and let's say there was some code that asked the user for input, and if the input was quit, the word quit, that means you would stop. But as long as they don't say quit, you play. Let's say it was a game that keeps playing over and over, and after the game is over, you ask the person, do you want to quit? What would you like to do? And if they say anything, you play another game. But if they type in, let's say, the letter Q, then the game quits. So how could we code up a for statement that says play this game 20,000 times? They might quit after 2 times. They might play all night long. You don't know when they're going to stop. So if we had something like let's say, that's really kind of a different lecture. Let's just say, for example, we had a way of saying get input from the user. So let's say this was something we could say and it'll get some input from the user. And then this equals the input. Input string equals whatever came back from the user. If the input string equals quit, then we stop. But if it doesn't equal quit, then we go again. How could we keep something going over and over and over that way? So what we can do, and so the issue is really this, it would be like a for loop, but the problem is we don't know when we're going to stop. When the for loop started, we have no idea when it's going to stop. So it's outside of our control. So what we can do is we could say, trying to, you know what, maybe, does that make sense that the input, like, we can't control when the person's gonna decide they wanna stop playing? So, okay, so we could say that we could use a thing called a while loop. And in the while loop, we put in the condition, as long as the so this is something that's gonna be either true or false. As long as it's true, we do one more loop. As long as it's true, we keep doing one more loop. And if it ever becomes false, then we're done, we skip this loop. So we could do something like while, and then the condition could be, I'm trying to stay away from the idea of the input string, because it goes into a different lecture. So let me do this instead. Suppose we had a problem that worked like this. You start with a number I equals 0, and you want to print out all the numbers. No, I'm sorry. You start with I equals 1, and we want to print out the number I is equal to times the previous number times 2. So we want to print out 1, 2, 4, 8, 16, 32, and so on. Let's say we wanted to do that. And we decided once I is less than 100, or once I is greater than 1,000, we'll stop. What we could do is we could say while I is less than 1,000. And we could say system. We could print out I. Okay. And we'll let I initially be 1. And then what change do we make to I? So in the for loop, this kind of represented the condition that would make us stop. The condition we started with is actually moved outside of the while loop. Remember in the for loop, the first thing was where we start. Since this is just going to test, is this thing true or not true? And if it's true, it's going to do another loop. If it's false, then it's done and we go finish whatever comes after. So we would want to put inside this code, if you remember the last time, the for loop said what do we want changing each time, and we said I equals I plus 1. Now we'll encode that into the body of this while loop.
Did you
So,
go above system or below?
I guess we wanted, first we'd like to print out the value, then compute the next value. So we'll say I equals I times 2. And then we'll check, is I now still less than 1,000? If so, print it out and double it. Print it out and double it. And this will just go on forever, and this will go to 128, 256, 512. The next one would be 1,024. So it become 1,024, and that's not less. This statement is no longer true. 1,024 is bigger than 1,000, so it would stop right there. So this program would have this as its output.
Is that just another way of doing the for loop?
Yeah, so in this particular example, we could have, I wanted to have an example where we could do a corresponding for loop. And generally, people will argue anything you can do with a while loop, you can do with a for loop, so it ends up being what you like more. But what would be the equivalent? How could we write a for loop that would print this as output? We could say for int I equals 1. The condition that we're checking, we don't hit, is still I less than 1,000. And each time we do this, we want to take I is equal to I times 2. So it doesn't have to always be I equals I plus 1. It could be I equals I times 2. And then The body would be just print this out. That's what system out, print line. Both of these programs, this is the while loop version and this is the for loop version. We'll put a close paren here instead. Both of these would print out the same output, this output.
Right.
So there are two different ways of really doing the same thing. So now the question is, why have both ways if they both do the same thing? A while loop is a little bit more clumsier, I guess, because you have to set up your initial condition outside of the loop, whereas in here it's actually part of the definition of the loop. This is the thing that will terminate the loop, and then inside the body you have to code up what happens, what is different each time the loop goes through. But sometimes in the real world, there might be a situation where we don't know when it'll stop. Like I is less than 1,000, we know that's what makes us stop. But if there was an example where we were using sysin and polling the person for input, well, if they gave us input like the input is quit, we could then make our condition if input equals quit, we could put it here. Yeah, put it here, and that would be the terminating condition. So really, this ends up being just whatever you're more comfortable with.
Like, would a while handle that instance better for some reason,
Not,
or it
I
doesn't
mean, I
matter?
guess not really, because whatever is here goes here. Whatever is here, this is the terminating condition, that goes here. So these two go together. This would have to be set up outside the loop. And then what changes at each step, this part here, has to somehow be put in the body, and it would end up being done last. Because, it would end up being done, this loop will not run if this is initially false. Whereas this loop, no, yeah, that would be fine. Yeah, so this would go at the end. And that tells you after all the stuff that you're trying to get done with each loop, you make this change and then you come back up and retest it.
Now, for an instance where, like you were saying, the user has to input for it to stop, you know, does there always have to be a cap?
I think, well, otherwise the loop would run forever. There has to be
So there has to be a
there has to be
cap,
some,
even if the user would never use the cap, would never reach the cap.
right. So the stopping condition in a for loop is the second thing of the for line. And the stopping condition for the while loop is what's ever in the while. And those would match exactly. So if we wanted to have something we don't have control of, like one thing where people would always use a for loop would be if something's gonna go from 1 to 1,000. You know the start number, you know the stop number. It's kind of intuitive to go from 1, as long as you're less than 1,000, do the following steps. Intuition kind of says if I don't know when it's going to end, for example, if you're polling a person saying, would you like to play another game, and they might say no, or they might say yes for an hour, you keep asking them until they stop it. It's kind of intuitive to code it up this way. But the truth is either one can be used to code up the other one. And there's another one called the do while, which,
Yeah, where you can, I guess have simultaneous loops or something?
well, no, what you're basically doing with a do while is, you could say do, open paren, close paren, some stuff, and then you'd say while, and you'd have a condition. And the only difference between this is you're guaranteed to go through the loop at least once. You're saying do, so you're saying perform this task is true. And then if the condition is true after the first pass, then do it again. So the only difference, if the while here, if this condition failed the first time, we would never go through this ever. But the do, you go through it at least once. So if it's something that you know you're gonna do at least once, it might make sense to do the do while. But again, this is an intuition thing. With any one of these loops, you can make the equivalent. You could always set the condition up here to be guaranteed to be true at least once, and then have it become false in the body. So
Okay.
the do while is not too popular. Okay. And then there's the idea of suppose what was in the body of one of these loops was something that starts getting a little bit complicated. And this isn't a complicated example, but suppose inside the body of the loop, suppose let's go back to the for loop. For I equals 0, I less than 20,000, I plus plus, that means I equals I plus 1. Suppose we had, now let's say we're back to we want to give interest to accounts. Suppose we said, well, if the account counts sub I is less than $100, they don't get interest. Let's say there's all kinds of bank rules there. No. If it's less than $100, we subtract a fee from them. Insufficient funds fee. Accounts I equals accounts I minus $3. Something like that. And then if they're above $100 but less than $1,000, they don't get any interest. And then over $1,000, they get interest. Let's say that was a rule. So then we could say if accounts I is greater than 1,000, then they get interest. And let's say interest is 2%. So now we go through all the accounts. Anyone who's under $100 pays a fine. Anybody who's over $1,000 gets interest. Now you know the way banks can be, these rules can get more and more complicated, right? So there could be more lines that we do each time. But what if we decided every day we want to go through all our accounts and do whatever updates are needed for that day, but maybe this fee only gets charged once a month, but maybe interest gets added once a week, right? Then we couldn't really put these two together. These are kind of separate tasks, and so it might make sense to describe these tasks as something separate, right? So it might be good if we could somehow do this. Instead of subtracting a fee, suppose we were able to just say something like this. The thing I just erased, I'll say charge fees. If we could do something like that, just say charge fees, and the stuff that I just erased would get done by just saying charge fees. That would be kind of good. And then maybe this would get erased, and this would be add interest. If somehow charge fees and add interest could mean those things I just erased, this would work out nice. So this ends up being, if we decide we have, now I didn't make the charging the fee that complicated, but it could have gotten more complicated. What we might do is have what's called a method, which performs a task every time you say its method's name. Whatever that collection of tasks is, that would get performed. And we could define a method by saying, this is not the perfect syntax, I'll clean this up in a second, but we could say something like this. Charge fee, fees. Don't worry about what this is yet. And then we could say, accounts. No, it'll be it will be, okay, sorry. We're gonna charge a fee for each account. So we have to somehow say, for account I, we would like, sorry, this should be if account I. If accounts I is less than 100, then accounts I equals accounts I minus $3. Now the problem is we have to somehow tell, we don't know what the value is of the value of I is up here, not down here. So you have to somehow pass it to, when we call this method, we have to somehow pass it. So that's what this open paren, close paren thing is. So we'll say there's an integer coming in, called I, and that's how we'll pass it down. So this ends up being what's called a parameter. This variable is being passed to here, and now this is, you know what, let me use a different value for I down here. I'll call it II, just to be different. II. Just to show it's a different value. But what I'm saying is, I is going to go from 0 to 19,999, and then I'm going to call this method, which performs a sequence of steps, but it's going to be the same steps over and over, so I'll just give it a name here and then define it somewhere else. And then later on, if the bank changes how it does its fees, we just make the change in one spot here, and this will stay exactly the same. So, this method in the programming language Java, this method has to actually return some value. You have to describe what it's going to return. And this method happens to be returning nothing. We could have had a method that performs some computation and then returns an integer, but we happen to be returning nothing. So we want to be able to say right here what it is we're returning, and they use the word void to mean we're returning nothing. So this method is basically saying its name is charge fees. It takes in a parameter we're calling II, and then we're saying if accounts II is less than 100, then accounts II equals accounts II minus 3. We'll subtract $3 from them.
If the parameter int ii is different, II and not just I, how is it taking in the parameter of I above?
So, yeah, that's a very good question. Up here we have a piece of storage called I, which let's say, as this thing is looping through, is currently equal to 95. Right, it's gonna go from 1 through 20,000. If it's currently equal to 95, this function has a completely separate piece of storage, and I use the letter II just to make it understood they're different. This has its own piece of storage called II. When this method, charge fees, is called, you're saying, run this code and then come back here, is basically what we're saying. But I want to pass the value of I, 95, I want that copied into here. So that copies the 95 into here.
Even though it's named II?
Even though it has a totally different name. Because in regular code, we could say A equals B, right? And if A was equal to 10 and B was equal to 20, if you run this line of code, A will become 20. A takes on the value of B.
So somewhere in there, doesn't it need to state I equals II?
Yeah, that's kind of true. So it's being implied because
Oh, okay.
because we're calling the function and saying, I'm giving you I, and the function defines that says, I expect something to be passed to me, it is kind of implied. That's a good point. It is implied, but it's not.
Will it compile without it saying I equals II?
You're saying, shouldn't there be a line, something like that?
Yeah.
It is implied that that's what this means. Because this parameter lines up with this one, this value got copied into it. It's kind of like that line was executed. And you don't have to say it, it's implied that that's what
okay.
you mean. But yeah, that's a very good question, and that's exactly what's happening. This piece of storage is different from that one. Now, when I wrote it before, I had one I here, and I kind of know what that means is this I and this I are two different I's, which was confusing. That's why I said, let me change it to II to avoid that confusion. But if I left this with one I, there'd be an I here and an I here. Same letter, but two different pieces of storage, and that's, I know, a little confusing.
Okay.
So I just made it II for now, just so it would look different. And now what's happening is when we call this method, we're basically passing whatever this value was, got copied into here, and then this line of code was executed. Same as before, but now what we've done is we've made a separate function, a separate method. I keep saying function because in C++ and C, this would be called a function, and in Java it's called a method. So we have this method, and every time you see this word, now this code runs, and then we come back. And then we can make the same method for add interest. We could write a separate void method. And then when we get more into classes later on in the course, there's a distinction between methods that belong to an entire class and methods that belong to each object. And methods that belong to a class end up having a distinction called static in front of them. And that would mean there's one for the class. So then, and we'd have to actually, in order to have this method, we'd have to make an outer class called like bank functions or something like that. And then this would be a static method of bank functions. But like I say, that'll make more sense when we talk about classes. But just for now, even though this isn't proper Java, it just gets the point across. We can actually take any subset of tasks, any set of lines, and make them separate and give it a name, a method name, and then anybody who wants to perform that particular task can just call that method. So if there were 3 other applications that also charge fees that the bank wanted, it wouldn't make sense to write the logic. You know, like the logic says if your account balance is less than 100, then we subtract the $3 fee. It wouldn't make sense to write that code 4 different times because it's needed by 4 different things. It would make more sense to write it once, and then all the code any code that wants to use that would just call this method. And then if the bank decided we're going to a $4 fee, you just change it in one spot, and everybody who's calling this method would pick up the same code.
Now,
So-
in like the real world, when you're programming for a certain project like
Right.
that, you work with the software engineer, like, the way that everything is mapped out in flowcharts, or?
Yeah, so something like this would end up being, I don't know if it would be in a flow chart, but if there are separate functions that your application, so that could be a group of people working on something, if there are functions that are going to be, a function that's going to be needed more than once, by more than one piece of code, it generally makes sense to have a separate method for that. So that way, if the bank ever needed to change something later on down the road, you change it in one spot, and if anyone's using it, they would just call it by name. So yeah, really, this is obviously optional, just like those for loops. We could have gave interest by copying the line 20,000 times. It's just that it's a lot easier using a for loop. This ends up being, it looks initially like more overhead, because I had to make up a name for what we're doing, we're charging a fee. I had to make a separate method, extra open paren and close paren, and then anytime someone wanted to use it, they had to say it by name. It looks like a little extra work at first, but maybe down the road we'd have a lot of savings.
Right.